Hello again. Alright, so we've talked about the properties of exponents, and we've used examples of those properties of exponents using whole number powers, positive whole number powers, positive integer powers. But it turns out you can also have powers that are zero, you can have powers that are negative, and you can have powers that are fractions. They're called rational exponents. So the first thing we need to do is talk about what happens when you have a zero power. What does it mean to raise a variable, or raise a number for that matter, to a zero power? So let's go ahead and talk about that. So what does it mean to have x to the zero power? Well, there's two ways I can explain this to you. The first way I want to explain it to you is to look at this expression right here. X to the fourth over x to the fourth. We had a quotient rule a number of videos back, one of our properties of exponents, that said that if you have a quotient where a variable in base, a same base, top and bottom of a fraction with two exponents, that the rule was you subtract those exponents. So this is x to the 4 minus 4. This is x to the 0. So this is actually an expression that is equal to x to the 0. But you know what? What else is x to the 4 over x to the 4? What's anything over itself? You know the answer to that, don't you? What's anything over itself? 1. So x to the fourth over x to the fourth is 1. What did we just prove? We proved that x to the 0 equals 1. X to the 0 power is 1. How about a different way? Let me prove it to you a different way. How about I have, and let's use a number this time. What if I have 2? 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and so on. 2 to the first is 2, right? 2 to the second, 2 times 2, which is 4. 2 to the third, which is 2 times 2 times 2, which is 8. 2 to the fourth, which is 2 times 2 times 2 times 2, which is 16. So how do I go from one number to the next? I'm just simply multiplying by 2, aren't I, to go from one number to the next? So how do I go backwards? Well, if I'm multiplying by 2 going to the right, 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So 2 divided by 2 should give us 2 to the 0. 2 divided by 2 is 1, ladies and gentlemen. It's magic. No, it's math. 2 to the 0 is 1. Anything, let's go ahead and write it. Anything, and we'll say it quietly, except 0. To the 0 power equals 1. Anything to the 0 power equals 1 except 0. I'm not going to talk about 0 to the 0. It's undefined. Has no meaning for us at this point. Okay? But you won't come up against a problem with 0 to the 0. It just will not be in problems. But anything to the 0 power equals 1. Anything at all. If I use my x in the same way, x to the first is x. X times x is x squared. X times x times x. To go to the right here, it's times x times x. So to come backwards, we're dividing by x. We're dividing by x. So x divided by x is 1. Anything to the 0 power is 1, which leads to really, really tricky, guys accuse teachers sometimes of having trick problems. We don't do it that often, but here is definitely a trick problem. Oh, I've been known to give problems like this. Answer to that? 1. Anything to the 0 power is 1. Don't do all this stuff in here. You don't need to. It's all raised to the 0 power, which is 1. What does that mean in terms of problems? For example, if I have a problem that looked like, I'm just going to come up with a problem here. What if I have x squared y to the 0 times x to the 3rd y to the 4th over x to the 0 y to the 2nd squared times xy? What does that mean in terms of problems? It means that any term that's raised to the 0 power is 1. This is 1. This is 1. So if you replace those with 1s, I hope you can see that that just simply means they can be disregarded. So if you have a problem where you have a factor raised to the 0 power, you can disregard them because they're equal to 1. There you go. And that's 0 powers. Next up, negative powers. Thanks.